In the last video, we have created the skeleton and implemented the 9 packages and also a enum class in our backend project. Everything except it was empty. Today, we are going to fill up those packages and also implement the model class and remaining enums. And we will implement the strategy pattern in this. So from now, we are starting the real Java programming. So let us move to write the classes. Most of the tutorials on YouTube are following their natural way of implementations, but we are focusing on order of writing the code. So this part is the order we write code in, which differentiate us from different tutorials. So we are going to follow one strict rule as to write the interface before writing the class that uses it. Why it matter to write the interface before writing the class? So the reason behind it is because if you write the concrete class first and then you write the interface, so you are implementing in a specific order, like implementing in a more specific thing from very specific to the journal. In this order, we will write the interface first, then the interface will force us to think about what object do, not how it do, not how it is working. First, we will implement the interface, which will decide what the object of this interface will do. Then we will write the concrete class of it. It is basically the dependency inversion in action. Not dependency inversion is not just like the diagrams and arrow. It reflects on your writing ability of the code. So we are writing the interface first, then the class to know what the object will do before writing any code, before writing anything. So the user class is a class of authentication. So in authentication, we will create a class. Class name is user, as user is a model class. So for user, have some private variables. So private string ID. Then we will have name of the user. Then we will have the email. Then we store the password associated with that email. And then we will store the role of that user. So it is private string name. It is the name of the user. Then private string, then private string email of the user. Now private string password, the user. In future, we will create a encoded password. So don't worry now. Role type for role. It is a role type for role. So why you have taken a role type for role, not a string? What if you take it a string? So a string is not pre-decided. Okay, we have certain number of roles in our project, like user role and admin roles. Let us take a enum of role type to make this. So let me make a enum class, enum package where we will store the enums. We have in auth sub package, we have a enum package in which we store the enums which are required in auth. So the first enum which we required in auth is role type. So change the class to enum, and now let us import it in user. So we can import it like option and enter we will press, or we should click the import class. After importing, you can see the import package. It is the base package, and this is the sub package. Then now the auth package, then enum, then the role type. Let us fill the role type. Okay, what will be here in enum? So the enum will contain user, or maybe it's admin. So currently we have two role types, the user and the admin. Now we should have getter and setters. So that's why we have used the Lombok have the capability to generate the getter and setter. To generate getter and setter, we will just use the Lombok getter and setter. As you can see, there is a Lombok getter and setter. So just click it and use it. Lombok getter and setter, getter and also setter from the Lombok setter. Okay. So it will generate the getter and setter of this variable like ID, name, email, and password and role. Why we are not having a data here? Because we can have the data. Also, we can use one specific part of data, because data contains various things inside it, as it will generate the getter, it will generate setter, and it will generate toString and various types of method the data annotation can generate. So this is also a important interview question, as why I have used the getter and setter here, not directly the data, because data annotation is very popular, but it's quite risky, as data annotation auto generates various methods like equal method and hash code method and toString method. It will automatically generate by taking our variable ID, name, email, password, and roles. So it sounds quite good, but in production, when the user will link to the any other object, like let's say the user is linked to the list of bookings, or the booking and user call each other in their toString method, it will generate infinite recursion, and it will provide a stack overflow exception in your production. Okay, that's why we have not using the data, using the getter and setter. Currently, we need only two things like getter and setter. So we are using getter and setters. Do not use data, because we are not currently using its toString method, hash code method, and equals method. So when we need these types of method, we will use another type of operations. I will tell you later. So let us see how data is generating that code. So to see it, we can just open the data class inside Lombok. So this is the package Lombok, and this is the internal class implementation of that Lombok. And it imports Java's annotation like element type, retention, and all these things. So this is a interface which which also have like getter, setter, required R constructor, toString, and equal and hash code. And so we can also take up to the documentation of it. So on going to the documentation side, this is the pure documentation of Lombok, as Lombok generates toString, setter, getter, equal and hash, and these types of things. So in vanilla Java, we can see what type of code the @data is generating. So this is the data example class we have, and we have the in predefined arguments. The argument is string name, age, score, and tags. In the pure documentation of Lombok, we have getter, setter, get age, set score. So these are the getter setters. This is the toString method, which is also generated, and equal method, which is also generated, and hash code method, which is also generated. So that's the use of Lombok, as just provide @data, it will generate these type of code. You can see it in the website like projectlombok.org. So now let us move to our code, and we should remove the data. And we are using the things we currently need or we currently know. Adding builder, builder from Lombok. Now, what's the use of builder? Builder will generate the code which is helping us to call and make the constructor in very easy way. Let us see how the builder is helping us. So the builder is helping us to create the object of user class, as it will create like the user, and it is the name of the object, and user dot builder. This is the method This is a method it is using. So this is a dot builder method it is using. Now dot builder method will let us create the object. So this is the ID and we will provide the ID, and this is the name, we have provided the name, and this is the email, we are providing the email, the password, that's the password, and for role we have the enum for role. And now at last we have called the build method. So there are two main reasons why we are using the builder class. So builder annotation, one is to never end up with a half built object. What never end up with half built object, as we can never end our object creation without this dot build method at last. So whenever this dot build method will run, the object only then creates. Otherwise, you cannot skip any one item or any one argument in it. So the second reason is code read like a sentence. So the code here is already reading like a complete sentence. So the user have called the builder method and it is having the ID which is mentioned and name which is also mentioned, the email, password, role. These all are mentioned like a complete sentence. Okay, so it improves the readability of code. Whenever you submit any PR on GitHub or anything, it is completely readable how you write the code. It is very clean looking code. Okay, so now let us move it to it. Now our model class is done, our enum class is done. So now we have the seat pricing strategy earlier in our UML designing video, as we are using a strategy design pattern to see the seating prices. We are not using the data holding enums. So the interviewer might ask you that why not just putting the price multiplier as a field inside the seat type enum itself, because seat type enum can also hold the methods. So like normal 1.0 and recliner, we have the multipliers because enum can hold data too. So that's the question interviewer might ask about enums, as why we have used the strategy patterns, not the method with the enums. Okay. So answering this question, as that's a completely valid. So honestly, with the data-based enums and the prices are fixed and never changing prices. So enum with data even wins. But for our case, for our project, we are basically using dynamic pricing strategies, dynamic pricing project. Okay, we are using the prices which are contingent on based on the business and based on the time and based on various other factors. That pricing is always keep on changing. An enum constant, if we use a constant in enum, it got compiled with your code and got deployed. So we cannot change that constant on runtime. So if at the case of enum constant, if we need to change the price, recompile the project and redeploy the project to see the visible changes. And on the other hand, the strategy pattern design can be reloaded and reconfigured from the database itself. So that's the complete strategy pattern in real implementation, as this is the difference which creates in someone who just use the strategy pattern in designing and someone who know the actual depth of strategy pattern usage. Like our use is dynamic pricing, which need the strategy have the runtime flexibility of pricing, which is not maintained by enum with constants. Okay, so that's why we have used the strategy pattern here, and we mentioned the whole scenario why the strategy pattern is best for us, not the enum with constants. Now we can see the actual diagram of the seat. So here is the actual UML diagram of seat, which will have the get price method, and there is an interface of ISeatPricingStrategy, which have get price, which takes a double base price and return a dual. Okay. So now let us implement the interface and then implement the input this interface like normal sitting price, recliner sitting price, and VIP sitting prices. So let's go with the seat. Okay. Now seat type have the normal, recliner, and VIP. Let us create a interface. To create an interface, we have a Java class. So the Java class is an interface. So we will select interface and make it as I seat. What is seat pricing strategy? Okay, seat pricing strategy, pricing strategy. Okay, I seat uh, strategy. So why here? As you can see here is a C sharp convention. Why we are using here? We are using here just to UML diagram convention to the Java convention, but it is not a Java standard convention. We generally not use I here because it is interface already. So we are having a C sharp convention here to just maintain a link with the UML diagram. Okay. So we have a I here. So now what the interface holds, a method which is like double, we can see here get price, double get price, which will take double base price. That's the method we need. This design is to use first design in which we know what the object of I sitting price will do. So now let's create the implementation of sitting price Java class implementation. So first take the seat, normal seat pricing, normal seat pricing. We have normal seat pricing. Okay. Now to implement this, we can override the methods present in the parent class. So in parent class, we have a get price method. Now we will have our multiplication as we have 1.0 multiplied with base price. So simplify this base price into one. Simplify is as directly base price, or we can convert it to just dual. Okay. Now also we will have recliner. Can take the recline. Let us make a recliner sleeping pricing seat pricing, not sitting price, it's seat price. Recliner seat pricing, which also implements the I seat pricing that implement method. That's it. So in which we will have base price into. So now into is 2.3. So we have 2.0 as input. Okay. Similarly, we can have another class of VIP seat price. So seat VIP seat pricing, which also implements I seat pricing strategy, will have the implementation. I seat pricing will have the implementation, like we can have the options. So implement method return. Now it is 3.0. So now we have three classes: normal seat price, recliner seat price, and VIP seat pricing. And there is a seat type enum also. So for safety and clean look, we can make a package of enum. We can make a package of enum and put our seed type in it. Let's refactor and delete this. So seed pricing strategy. Okay. Now we have seed pricing strategy, normal seed, recliner seed, and VIP seed. The package by feature is already profiting us, as all the seed price strategy are belongs to the seed class only, not goes to the another classes. As if we were not using the package by feature, the strategy method, the interface will be in another class and all the implementation will be in other class. So now we are in profit that we used the packaging with feature, which says that all the classes belong to one domain will reside in domain subpackage. Now it's time to implement the model seed. So we have a seed model class as we have implemented the user. So now what are inside the seed is ID. So we can have private string ID. Also can copy it and just paste it. Also seed number, we can have seed number. Also we row and screen ID. So row and now seed type. So we seed type, seed type. Now it is time to connect the button with a object. Okay, this is the main linking of our strategy class to the main object class. So that ensures that the seed does not know about whichever seed type disconnected. It just know a method which will be a get price method. So to connect it, we have ISeatPricing pattern as so ISeatPricing strategy. Now there will be a method which will return dual the price of the seed as a get price method which will take a base price and return the ISeatPricing dot get price, take this base price as an argument. So that's the complete class of seed which is now connected with the ISeat strategy and have a get price method. Now seat is not directly linked with the normal recliner or VIP seat. It is completely decoupled and based on a strategy pattern. So into the auth strategy. So for now, we are just making a stub, not the complete authentication, because for complete authentication, we need various libraries. For complete authentication library, the auth-token string, which we are returning. The implementation part we will see later on a very most long video of security. Okay. So for auth strategy, we can see as in our diagram that IAuthStrategy is an interface which has authentication. Authentication needs the email and password, which return auth token. The auth token is coming from the JWTAuthStrategy. Now we are having the JWTAuthStrategy with the incomplete implementation. We can have incomplete implementation. There is no shame in having the incomplete implementation. Companies sometimes keep the stub to just test and compile the application, as when there is a unprepared payment system, when there is unprepared email notification system, the companies sometimes make the stubs to make a ready to use application with a complete flow and complete testing flow. Okay, so do not get worry about the stub. We will implement it later in a complete video. So now let us make a ISeatPricing interface. So in auth, we are having an interface. So in auth, let's have an interface. Interface is IAuthStrategy. IAuthStrategy as an interface. IAuthStrategy is a interface. The interface will have a auth token returning authentication method. So to have a auth token, we can have a Java class of auth token. So now auth token is a string. Let us have a string, private string token. So this is the auth token, and we are using a Lombok to generate the getter and setter. So now auth token authentication, which will have a string email and string password. Okay. So private auth token and password. So to take the auth token import, we can import it like this auth token. So it is not importing because it is in same class. I think why it is having an error. Private method in interface. Okay. The error is gone. Now we have a IAuthStrategy interface, which return a auth by taking the email and password. Now create its implementation. To create its implementation, we will create a JWTAuthStrategy. This is a complete stub which implement IAuthStrategy and have a method with its authentication. Now the authentication will use authstrategy dot builder. It will return new authstrategy dot builder, not this authstrategy dot. Why we are not having builder here? I think I have not used it. Okay, so let's also include builder. Now this will builder dot build. Okay. Now after builder, we can include the things. So we have ID here, token. So the token will be dummy token. Let us, it need a string now. So dummy token, and let us include the email here. So now it will provide the auth token. So auth, let us mention here as we will have a complete JWT implementation later, as this is a stub for now. So this is a complete JWT authentication system as a stub. So that's done of now. Now moving to the auth manager, it is, I think it is having some issues. Okay. So now IAuthStrategy have user repository also. So to build user repository is interface. Now let us build that interface. So to build that interface, we will auth and now select the Java class interface. So the interface is user repository. Now click OK. So to build this user repository, we have a method save and a method exist by email and a method find by email. To have a save method, it will take a user of user. Now it will return void and method save. It will take the it will take user of. We will define the methods only, not the implementation, not the concrete class. So now we have find by email. Okay, find by exist by email. So if exist, we need the user. If exist, we need the exist by email of email. Now we should use a optional here. Optional. The Java util optional is also imported. Now, why we are using an optional here, as you can also done by the user. We use optional because it is having a compile time safety, as whenever the method is returning any optional return type, it means the caller needs to explicitly handle the null things. As when there will be a null user, the caller have to just make sure that it handles the thing where no user is found. So exist by email and find by email. Find by email user, and same as find by email, we'll have this. So exist by email, and this is find by email. Find by email. Okay. So that the dependency user we have created. Auth manager class is done. Now let's see. After our making the stubs, repositories, and implementation interfaces and strategy pattern, we used all these things. Now let us rerun the project and see is anything broken or it is running completely right. So enable the annotation. So okay. So the project is running quite good. So it has started, and it is PID default and port 8080 also, and it is completely running properly. No exception, no error yet. So now in this video, we have covered the strategy pattern, and we have included the various enums here like booking status, gateway type, payment status, and enum in role type. So let us make it good. And now we have seen our project is running quite good, no exception, no error. So in next video, we will see how the implementation of auth is working, and hopefully in the next video we will see how authentication is working in memory, uh, and how the registration is working. We have not used any database yet, so the all will be the in-memory storage. So in next video we will see how the registration is working in auth manager. Thank you, stay tuned.